In this video, we'll be talking about linear equations. Linear equation simply describes a line, okay? It just gives us a line. And these kinds of equations are linear equations, okay? The general form is ax plus by equals c, where either a or b or both must not be 0, okay? And slope-intercept form is the most widely used form. Y equals to mx plus c, okay? M is the slope and c is the y-intercept. And point slope form, if the slope of the line and the point through which it passes is given, then this is the equation of that line. Why are we studying this linear equation is since we collect data and we plot it in a graph, right? And then we try to see whether there is any characteristics that we can point out using college algebra, okay? Now we know that there is scatteredness of data and all the data are not uniform, right? Just like, let's suppose if you take your budget for an entire year from the last year, then you may see that you won't be getting a straight line for that, okay? There may be dispersed kind of data, okay? And then you might want to approximate that data by using a straight line, okay? Which is not perfect, but it will approximate and it will give us an idea what is the trend of your expenses throughout the year. Then you can make predictions if that kind of trend continues, whether you would be spending more or less or somewhere around in some kind of range. If the data were quite nice and it followed a straight line, then we wouldn't have studied statistics. However, since in reality the data points are quite dispersed, but we should be able to find some kind of trend, approximate trend. Okay, so that's why we are studying statistics. And in this chapter of regression, we will talk about regression lines. Okay. Moreover, we'll be concerned on this equation, okay? And I will use GeoGebra and Microsoft Excel to show you how we can scatter plots, and we will get a regression line, the correlation coefficient, and everything that we need, okay? All right, so let us go for this slope-intercept form. And here, I must ask you to understand that this y equals to mx plus c. This is the widely used line, okay, straight line, and this is the slope. What does that slope means? It's also known as rate of change, just like 20 miles per hour. That's the speed of your car in such and such a route. Rate of change, right? And now here you need to realize that amount of change. This m is the amount of change in y, in this variable y, for unit change, means 1 unit change in x, okay? So this is the key concept that you must understand about the slope, okay? And I emphasize this thing to every student, whoever is studying either college algebra, preparatory algebra or statistics, to understand this concept very carefully and write it several times in your own words, okay? So m is the slope or rate of change, which means it is the amount of change in y for unit change in x. Suppose if you have let's say y equals to 0.75 x plus, let's suppose 3, then for 1 unit change in x, if x goes from 1 to 2, then we expect that this y will change from 0 to 0.75, something just like this, okay? All right, so if this is negative, then you will understand that if the slope is negative, then y will also decrease in similar fashion. That's the key concept that you must realize. And also you need to do the entire calculation and things will be slightly different, but this is the idea. Okay, and then after that, what is this one? C is the initial value or y-intercept or initial value. What does that initial value mean? Whenever x equals to 0. Okay, whenever x equals to 0, y equals to c. So that's what we need to understand. Now, as we start to scatter plot the data in either Excel or GeoGebra, we will see that this y-intercept won't make any sense in many cases. Okay, we should be very careful about that. Okay, we will realize that. Okay, now let's head over to this y equals to mx plus c. Okay, slope-intercept form. This value is c. Whenever x equals to 0, y equals to c. Right? So that's it. And this equation is, let me write down in this way, a plus bx. Okay, so this is how statisticians write down the slope-intercept form. B is the slope in this case. So here the regression line used by statisticians are represented by y equals to a plus bx. And more specifically, the statistician there want to write y hat equals to a plus bx. All right, where x and y are two variables. Okay, x, this is the x variable. Okay, this line will represent x variable and this line will represent y variable. And the basic idea of a regression line is to see whether there is any kind of correlation between the variable x and variable y. Just like, let's suppose x represents height of the students in our class, and let's suppose y is their corresponding weights of the students in our class. Then there could be some kind of correlation in between them. And what is the correlation? And this y hat is assuming that this is approximate. Okay, it's not saying that it's perfect, it is just saying it is approximate. Okay, and this b is the rate of change or slope. That means this is the amount of change in weight, which is y. Okay, for change in x or height. Okay, that is height. You need to interpret these things in this way. Now, unit change means change in 1 inch of height or 1 centimeter of height. That could be the thing. Okay, so either you choose centimeter or inch, that's up to you, or that's up to the question how it is given. So this is the way how you need to realize. And a is again the y-intercept, and this may be irrelevant, or it may not be logical. Okay, since x equals to 0 means there won't be a person with x equals to 0 height, right? Okay, so a is irrelevant in this case. So that's the basic interpretation, and you must be able to interpret the slope in this way. Okay, amount of change in y according to 1 unit change in x. Change means either it can be positive or negative. Okay, so this is all for this video. Thank you.